So our goal today is to deal with certain cases that initially you are not able to integrate, but by doing a little bit of substitution, we will be able to integrate, okay? And the process that we're using is a kind of a chain rule, kind of a chain process for integration. But we're dealing with these composite functions or these different composite functions that we can work with. But I will say this, that it only works in certain cases, okay? The problems that you'll be given are going to kind of be set up for you to be able to handle them, okay? Now, the level of complexity here can go from pretty simple to very, very complex. In AP Calc, they deal with very, very complex ones of these. But we're going to keep them relatively simple for the SL, but you need to know the process and be able to handle it, okay? And basically, the idea is this, okay? If you face some kind of an integral that you're trying to find, and you don't have any good rules for it, check to see if you can use U substitution, okay? If you still can't do U substitution, then if you were in another calculus class, you would learn other strategies for approximating that. Like there's a trapezoid process where you're taking areas of trapezoids and taking a limit and all that kind of stuff. All right, we're not going to do that for this class, but that's the idea there. So let's look at what we're actually doing here. It says if u is a function of x, all right, we have f of u that we're trying to take the integral of, okay? But notice, if we're taking the integral of f of u times du dx with respect to x, notice what happens. The dx's can cancel out, and we're left with the integral of f of u du, okay? So whatever that inside function is, we're going to integrate with respect to that, not just to x, okay? Now, just to kind of illustrate here, let's say that instead of using u's and stuff, we just make that g of x, all right? Now, if I'm taking the derivative of u with respect to x, that's g prime, okay? And notice here, if I use this and I multiplied both sides by dx, I would have du equal to g prime of x times dx. Okay? Does that make sense? All right, stay with me here. Don't get lost halfway through. Okay? So, as a result, check this out. If I have this g of x, or u, in some kind of a function, I used it to the r power. It could have been the sine of g of x. It could have been 1 over g of x. It could have been any kind of function, but g of x is the inside function. If I have that multiplied by its derivative dx, I can replace all of this with du, and I can integrate with respect to u. Okay? And in this case, if it's u to the r, I would just, the integral would be u to the r plus 1 over r plus 1. Okay?
Why would it be g prime of x times d of x instead of adding the derivative of x? If you're
I mean, that's
like
just how the rules work
Okay.
in there. It's going to be multiplication inside. Okay?
So it's kind of like we're taking the second derivative a little bit?
No. Let me show you here with this process, and I think you'll see how this is working, okay? Here we have 2 times 2x minus 1 cubed dx that we want to take the integral of, okay? So if I'm looking at this, the inside function would be what in this case?
2x minus 1.
Okay, 2x minus 1. Now, what is the derivative of that? 2. Okay? So, if that's 2, then I have a 2 dx that I would need to substitute out for du. Okay? So look at what I have. This one is set up for us kind of nicely. I have the integral of 2x minus 1 cubed times 2 dx. Alright? Well, we know that 2 dx is du. Okay? That's the du. So notice this is the u substitution that we're talking about. We're substituting out the things that are in terms of x. We're replacing it with u's. Okay? But also, look here. 2x minus 1 is the u. So really what we're doing is we're integrating u cubed du. Okay? What's the integral of u cubed?
1/4 u to the
1/4 u to the 4th. Whoop.
Because you're taking the derivative, the integral, and just, I don't know.
Okay? Now, we didn't want the integral with respect to u. We want the integral with respect to x. So what should we do at the end, do you think?
Plug u back into the...
We do need a plus c. We're gonna plug that g of x or that u back in, okay? So this is 1/4 times 2x minus 1 to the 4th plus c.
So what do we do about that du?
Well, just like when I took the integral of x squared dx, I just made it x cubed over 3.
Oh, so that's just...
du is like dx but with different variable.
Yeah, exactly. Okay, it's exactly what it is. Okay, it's just like the dx but with a different variable. Okay, and when you integrate, it's gone. Okay. Okay. Let's run through a couple of examples of this just to get used to it, right? All right.
What did we do with the 2 that was in front?
The 2, remember I moved it back with the dx. So
Okay.
2 dx equaled du. So in order to put the du in there, I had to replace the 2 and the dx with it.
Oh, okay.
Okay? Here's another example here. Okay, just kind of running through a whole process. Recognize the function inside what you're trying to integrate. In other words, recognize what your u is. In this case, what's u? X plus 3. Okay? Just the x plus 3.
Oh.
Okay?
Because the power isn't.
Now, if I do du dx,
That's just 1.
that equals 1. So du is 1 dx.
Why did you
where dx is 1? Because the
Take the derivative of x plus 3.
Oh.
Okay?
So many letters.
So,
I tried to find the numbers.
alright.
It's not math
So look,
anymore.
since it's just 1, I can just put the 1 in there, right? It's just times 1. It's our identity. So that right there is du. And I'm integrating from 2 to 5 u to the 1/2. Okay? What's the integral of something to the 1/2?
2/3 u to the 3.
2/3 of u to the 3.
Good. 2/3 u to the 3/2. Okay? Notice we we've done step 2. We got the rest of what's in the integral to equal the derivative of the function, so that's the 1 dx. We rewrote the integral as the integral of u du. And now we just integrate it as usual. So we just finished step 3 up here. Now we're going to substitute the original function back into the result, the original u. Okay? So that means we have 2 times x plus 3 to the 3 halves over 3. Okay? Now, if it's a indefinite integral, we just put the plus c.
Oh, because it's 2 to the 5.
In this case, we wanted it from 2 to 5, so in this case, we're going to use the fundamental theorem of calculus. So we're evaluating from 2 to 5. So we plug in the 5 first, and then minus, plug in the 2, okay? So 2 times 8 to the 3 halves over 3 minus 2 times 5 to the 3 halves over 3. Okay? Well, you guys can handle it. Alright? Now, one thing you could do to help yourself, you could factor out a 2/3. You could use a calculator. Okay, do whatever on this one. Okay? So we have whatever that equals. Okay? Alright, so we do the arithmetic and we get 7.63 approximately. Okay? Alright? Any questions? Okay. Let's try another one here. This one's a little bit more complex, okay?
Which one is the u?
That's a great question, okay? Let's look at this here. If we're finding the integral of x squared plus 3x to the 4th times 2x plus 3 dx.
Oh, the 2x plus 3 is the gx prime, the prime.
The g prime?
Yeah.
Okay.
So the u is x squared plus 3x.
Good eye, good. Alright, you look at what an inner function would be. This is a function, but it's just times this to the 4th. The 4th would be the outer function. The inner function, u, would be x squared plus 3x. So du dx,
2x.
du is just, wow.
2x plus 3.
That's a trickster.
So du is 2x plus 3 times dx. And notice right here, we have a 2x plus 3 dx. So I'm going to replace that whole thing with du. I'm substituting in du. Okay?
So you only knew that u equal to the first because it's in the fourth part.
Yeah, this is the inner inside of something to the 4th. At least that's what we're going to try. It may not work out, okay, but usually they give you ones that work out. Okay? So, notice here we have u to the 4th du. Okay? What's the integral of u to the 4th?
U5 over 5.
U to the 5th over 5. So now,
You plug in the original value of u.
exactly, plug in the original value of u. X squared plus 3x to the 5th over 5 plus c. And that is our final answer.
And if we were given a definite integral, then we plug in the values of that.
Yeah, and use our fundamental theorem of calculus. Okay?
That's not home.
So this isn't too bad. It's a process you got to know and you got to be careful with, but it's really not terrible. All right, now, it's not always going to be set up quite so pretty for us. All right? We may have to put in part. Okay? So here we have the integral of x squared over the square root of x cubed plus 5 with respect to x. Can someone figure out what u would be in this case?
X cubed plus 5.
That's right, okay? Now what made you choose that?
Because it's, I mean, x squared is easier to integrate.
Because
It's
if you
not like a
Take the,
x.
Or you could also
Okay.
also
if you will take like x cubed plus 5, like without part, it will be just like that if x cubed plus 5 is to negative 1/2 power times x squared. So that means that x cubed plus 5 is u.
Okay. You're seeing that that x cubed plus 5 is inside of that negative 1/2 power, inside the radical in the denominator here. Okay? And that's a good observation. So x cubed plus 5 would be the u. And like Nina said, we could rewrite this as x squared times x cubed plus 5 to the negative 1/2 power. Okay. Now, du dx is what?
3x squared.
3x squared. So what does du equal?
3x squared
Squared
dx.
dx.
Yeah, 3x squared dx. Okay? 3x squared dx. We've almost got it. Okay? If I rearrange this a little bit, I've got x cubed plus 5 to the negative 1/2, and I have an x squared dx, but I'm missing the 3, right?
Could we just do 3?
To multiply the x squared by 3 and then divide
Just
the
do the
Oh,
integral.
x
of
cubed
the-
plus 5
Hang on.
to the negative 1/2. Divide that term by 3.
Okay. So you're multiplying this by 3. You're saying divide this by 3.
Would that work?
What do you guys think?
Could you put a 1/3 outside of the integral?
Okay.
Maybe?
So you're saying do this.
Yeah.
What do you guys think?
Integrate
Wouldn't
the
that be a
first part.
3?
Good support,
Let's
guys.
try it. Maybe just integrate the first part. Maybe
Okay.
somehow there will be a 3 that you can multiply.
Actually, what those guys said were basically the same thing. Because remember, a constant multiple, if I put this over 3 or times 1/3 inside the integral, it's the same thing as multiplying by 1/3 on the outside of the integral.
Is
Okay.
that right?
Yes, that's absolutely right. So those were both valid ways of dealing with this. Okay? So that's good. Now you'll notice we have du. That 3x squared dx is du. Now don't lose this 1/3 that we put on the outside, because that's what made it possible to have du. Alright? So it's 1/3 times the integral of u to the negative 1/2 du.
or if we do the other way, if you do -half over 3.
Yes. Okay? What's the integral of something to negative 1/2?
Negative 2/3, 2, 1/2.
There we go. Yeah, you make it to the positive 1/2 and divide by 1/2, which is times 2. Okay? Now we still have this 1/3 multiplied here. Okay? But the integral of something to negative 1/2 is 2 times that to the 1/2.
So you just plug back what u is.
You plug back what u is. Good. So it's 2/3. If we simplify that 1/3 times 2 times x cubed plus 5 to the 1/2, or the square root of x cubed plus 1 plus 5 plus c. Okay? You getting the hang of it? A little bit. This is the kind of thing it takes some practice, just going over it, going through the process a number of times. So, I've given you a little bit of practice to try. I want to take really the rest of our time and just practice doing this process over and over.